Yes. So today's bell work is on our Lesson 5 guided notes. A survey found that 25% of people aged 18 to 24 gave up their home phone and only use a cell phone. If 2,364 people only use a cell phone, how many people were surveyed? Before we get started, are we finding the percent? No. Are we finding the part?
No.
If 2,364 people only use a cell phone, that is what 25% is. We want to find our whole. So I'm going to set up my two fractions. How do we write 25% as a fraction? 25 over 100. And we know that 2,364 is our part, so that goes in the numerator. Okay, so to solve our proportion, we multiply the two numbers we know how to multiply. 2,364 times 100 equals what?
236,100.
And what do we have to do with this number? And what do you get? 9,456? So 9,456, what? What's our unit?
Whole.
This is our whole, but how many what?
Oh.
People.
9,456.
Okay, today's lesson is on percent of change. Our target for today is students will be able to calculate the percent of change and determine if there is a percent increase or a percent decrease. We have a couple new vocabulary words that we are learning today. The first one is percent of change. A percent of change is a ratio that compares that change in quantity to the change or to the original amount. So we write that as the amount of change over our original to find the percent of change. If the original quantity is increased, then we call it a percent increase. And if the original quantity is decreased, it is called a percent decrease. Yes. For our first example, find the percent of change in the cost of gasoline from 1970 to 2010. So, which of the 2 years was our original? In 1970, that one came first. And what was the price of gas? $1.30. And did the amount increase or decrease in 2000 to 2010? It increased. So if you look at your percent of change, we want our amount of change over our original. And to find our percent, we can set that equal to the percent over 100. So if we're looking at our amount of change, if it changed from 130 to $2.95, you can subtract $2.95 minus $1.30 to determine how much it changed. What do you get when you subtract those? $1.65. So we have $1.65 as our amount of change. What was our original amount?
130.
$1.30, and we're gonna set that equal to, do we know the percent? No, so we're gonna do x over 100. What two numbers do we know how to multiply?
$1.65 times 100.
And what do you get when you multiply those?
165.
165, and we have to divide by our leftover number, which is $1.30.
0.0.
What do you get when you divide these?
That's 0.012 or 13.
165 divided by 1.30 is 126.92, and it continues. If we rounded this to the nearest whole number, what would it round to?
127.
127. It's a percent, so we have 127%. And was it an increase or decrease?
Increase.
So 127% increase for my answer. Okay, we also have another vocabulary word. The second vocabulary word is percent error. So the percent error is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. So we set that up as a fraction as well. Percent error is our amount of error over the actual. So it's error over actual, and when we solve for that, we're going to set it up like solving a proportion, and we're going to set it equal to percent over 100. Okay, so for our next example, suppose you guess there are 300 gumballs in a jar, but there are actually 400. We want our amount of error over our actual, and then we're going to set that equal to our percent over 100. So let's fill in what we know. What would be our amount error if we guessed 300 but there's actually 400?
300 over
How many were we off by? 100. So there's actually 400. We guessed 300. Our amount of error is 100. And what was the actual amount? 400. Do we know our percent?
No.
No, so we have x over 100. Go ahead and multiply the two numbers we know how to multiply. 100 times 100 is
10,000.
10,000. And what do we have to do with our leftover number? Divide by 400, and we get
25%.
25. So our answer is 25% or 25% error. Okay, I want you to go ahead and try the two on your own problems.